All right. We have to come into this with positivity. Gotta come positively. It's like, I want to learn this. Okay? I don't know it now, but I want to learn this. Once you understand the principles, it is not that difficult. Now, you do have to memorize it. You have to memorize it, but let's come in with positivity. All right. All right. We're going to take an example. We're going to do two. I don't know if I can squeeze in everything. I might do it in two different things. When you see simplify, a square root, in this case we're going to take 88. When you see that, okay, that is not, as I told you, one of the first things to do, if you don't know your perfect squares, put it in your calculator and see if the square root of 88 ends up being an integer. Okay? If it is a decimal, okay, there's more work to do. Okay, you need to make that note. Okay? When they say simplify, they're not looking for it to be a decimal. Okay? You got me? Okay, whether it's a square root, cube root, fourth root. So you go, okay, I put it in, I come out with a decimal. It's 9 point something or other. I don't remember exactly what it is. All right, so it's a decimal, like, okay, I have to simplify it. The next thing you must remember, I have to know my prime factorization. I gotta know how to do that. And with this, there's multiple ways to do it. I'm doing factor trees. Okay, I'm going to do a factor tree. You may have a different style. So I've got to get it into primes. That's the other thing. You must know your primes. Prime numbers. These are numbers that can only be divided evenly by 1 and itself. Okay? Any other number, it will be a decimal of some sort. Okay? Those are the primes. Now, we're dealing in Algebra 1. Pretty much, if you know your prime numbers from 2, which is the first prime number, up to 29, you're pretty good. So, and what the prime numbers are, I've written it before, but I'm going to quickly say it. I'm not going to take the time to write it down. Okay, so those of you watching me, write it down. 2, 3, 7, 11, 13, 17, 19, 23, 29. Okay. Pause the video and go back if you need to write it down. If you know those primes, and everything else is what's called a composite number. Composite, these are numbers that can be divided by not just itself and 1, but at least one other number. Those are composite. They are not prime. So you need to break down the composite numbers until they are you just have prime numbers left for all your factors. This is critical when you're doing this, when you're simplifying. All right? So let's continue. So I'm going to erase this now because you have to know we've done this before. So if you haven't, go back and watch that. So I'm just going to do this quickly, maybe a little bit slower since you folks are preparing for a game tomorrow. So I actually will try to do this slowly. So 88. The script I gave you, any even number can be divided by 2. Any even number. So when you're trying to break it down, you can't remember, if you don't remember your times tables, I really recommend that you know your times tables. But if you don't, when you're starting to break stuff like this down, go, okay, that's an even number. Even numbers are obviously 0 in the ones place, right here, ones place. Ones place. If it's an even number, ends in a 0, ends in a 2, ends in a 4, ends in a 6, or ends in an 8, we know it can be divided by 2. Okay? So it takes a while, but it's just easy, and just keep going with that. So I'm going to erase this now. And so I know this can be divided by 2. And 2 is a prime number. So I go 2, and I always circle my primes. Once I get there, I'm like, okay, I don't need to do anything else. That's a prime number. I don't need to do anything else. Twist this just a little bit this time. All right, so once you have your prime that is a factor, you then must take the number, that composite number, and divide it by that prime to get the other number. So this, you must go to your calculator, or if you know it by heart, 88 divided by 2. So I make this line. I know there's going to be something else coming. Don't make a mistake and put it down here. Okay, it splits like that. So 88 divided by 2 is 44. 4, go to the ones place, it's an even number. I know it is not prime because the only prime number that is an even number is the number 2. Everything else is composite. So I'm like, okay, I know this can be divided by 2. So I have another one. I'm like, okay, I'm not going to make a mistake. I know I got to find out what the other one is. It's 2 times something equals 44. Well, when I do 44 divided by 2, that's 22. And I go, oh, that's an even number. What can I do? Divide by 2. Circle it, it's prime. Don't make the mistake. Make sure I split it out. And then I go, okay, what's 22 divided by 2? If you don't know it by heart, put in your calculator. It's 11. What did I say? Make sure we know our primes. Is 11 prime? Yes. Know our primes from 2 to 29. Then we know this is prime, so I circle it. I am done. At least finding all of my factors that are primes, that when I multiply them together, okay, when I multiply them together, it will give me 88. I want to make sure I didn't make a mistake here. 22 divided by 2, 11. No, that's 11. Okay, doesn't seem like it's right. Oh yeah, 2 times 2. I'm like adding. What am I thinking? All right. Now, once you do that, this is what I do. I know that 2 times 2 times 2 times 11 is the same as 88. So I replace the 88 with 2 times 2 times 2 times 11. Now, you have to know this. This is a square root. Okay? Not a cube root, not a fourth root. Is that I know if I have 2 numbers that are the same, that are underneath the radicand, I know that's a perfect square. That I can take the square root. I know that 2 times 2 times 2 is actually 4. And the square root of 4 is 2. So I box any doubles. So I look for anything where I have a pair of anything. Now these aren't, so I circle these to remind myself, they stay under the radicand. This has to come out. So this becomes, so I know that this is the square root of 4 times, and this stays here, 2 times 11. Well, square root of 4, because you know 2 times 2 is 4, hopefully you know that's 2. If not, put the square root of 4 in your calculator, it'll be 2. And so this becomes 2. And 2 times 11 is 22. And so you end up with the square root of 22. So the answer is, for this one, 2 times the square root of 22. Well, you know what? For sake of time, I'm going to get another marker. What happens if it's not the square root, but the cubed root of 88? What changes? Well, the factoring doesn't change at all. I'm just going to rewrite it. It's exactly the same. So I'm just going to do 2, 4, 2, 22, 2, 11. No difference. No difference whatsoever. And I'm going to put it under the radicand. This time it's cubed root, not square root. Remember, square root's a little 2 here. All right. So again, it's 2 times 2 times 2 times 11. But here's the difference. With a square root, I'm looking for doubles. Here I'm looking to see if I have a triple. I do have a triple. So that's going to come out to the outside. Ooh, that sounds cool. Sorry about that. I mean to do that. Because 2 times 2 times 2 is 8. So this becomes the cubed root of 8 times, it stays under, remember, circle, the cubed root of 11. Again, hopefully you know the cubed root of 8 is a perfect cube, but if you don't, put it into your calculator, you'll see the cubed root of 8 is 2. So your final answer is 2 times the cubed root of 11. So that's the only difference when you're simplifying, okay, between a square root and a cube root. You must still do, again, there are different ways, but how I do it is I always want to get all my prime factors, find what those are, and then for a square root, I box the doubles, and for a cube root, I box the triples.